Alright, sorry about that once again. I had to clear some space off my computer. These recordings take a long time. So we're good to go to finish up this lesson. And it's going to be in three videos. So bear with us. We just got a couple more examples here. Example 10. So you want to use, we just finished going over this problem. I threw these formulas. Angle equals 1/2 big arc minus small arc, and angle equals 1/2 arc plus arc. So what you want to do is you want to take a second to pause the video. And see if you can figure out the angles in the arc. I will give you a big hint on this one. This big arc here is actually what we got to use this arc, not the 70. So can you think of how to get this arc? All arcs in a circle add to 360. So if you add these up and subtract from 360, you'll get the big arc. So that's going to be 125. And 360 minus 125 is going to be 235, I believe. So pause the video, see if you can work these out for X for letter A and for X for letter B, and then unpause it and I'll help you through it. Okay, so we're looking at letter A, and I noticed that my angle is in the center of the circle, or not in the center, but it's inside the circle. So we want to use this inside formula. It's going to be angle equals 1/2 arc plus arc. Now I want you to keep in mind something. The angle that's up here doesn't represent the two arcs here. You know, it's got to be facing those. So we actually can't use 120 for the angle. The angle are these right here. And notice they form a line. So these are going to be supplementary. So the angle is actually going to be 180 minus 120. That's going to give you 60. So I'm going to write 60 in there. Now we have the angle. We don't have one of the arcs. We're trying to find arc X. So, but its angle equals 1/2 arc plus arc. So the angle is 60 degrees. The arc, we have two arcs. We got X and 100. So I'm going to plug in 60 for angle. Arc is going to be X plus 100. And to solve that for X, since we're trying to find this arc, you might be tempted to distribute the 1/2 into there, but don't do that. That's too much work. What you want to do instead is you want to just times the 60 by 2. That's going to get rid of the 1/2 there, and that's going to open up it just to be X plus 100. 2 times 60 is, of course, 120. But then you just have 120 equals X plus 100. And at that point, we just take away 100. So you get 20 equals X. Let me recap this one real quick because there was a lot of steps involved. Step 1, subtract that from 180 to get the angle facing the arcs. Can't be the one not facing it. It's not going to work. Step 2, plug the angle into the number that the degree is for the angle into the word angle. Plug X and 100 in for the arcs. Step 3, multiply the angle by 2, get rid of the parentheses. And step 4, subtract the arc, and then you're left with the other arc. All right, down here, as you recall, we added these together and subtracted from 360. So this is the the formula that has the outside one. That's going to be angle equals 1/2 big arc minus small arc. And in this problem, we actually are given both arcs. We have to find the angle. So it's going to be x equals 1/2. Let me write the formula first. Angle equals 1/2 big arc minus small arc. I'm just going to write B and S. So it's going to be 1/2 235 minus 55. What's that going to get us? 235 minus 55 is I believe it's 180. So half of 180 divided by 2 is 90 degrees. And this, by the way, is not drawn to scale, so that definitely does not look like a right angle. But the way that it is worked out, this ends up being 90 degrees for that x there. So I'm going to write 90 in there. So 90 and 20. All right, we just got a couple more things left on our plate, and then we'll be done with the notes. Sorry about the 3 videos. All right, for this one, we got several rules. These are segments, not angles. So we're not going to do anything with 180 or arc or anything like that. These are legit just talking about the segments and how they relate to each other. So they look a lot like the other examples with angles, except now we're talking about how to get the sides instead of the degrees. So the first rule, this is the inside one again. I like to call this the part rule, because really it's just part times part. I used to teach as part times part equals part times part in geometry. It makes more sense than calling it letters, but basically how that works is these are A and B are 2 parts of the whole segment, okay? Of the whole chord is what we call it. So A and B would be like the 2 parts for that one, A times B. And then over here, the other 2 parts for this segment are C and D. And so if I'm given 3 of those 4 things, or if I can come up with 3 out of the 4 things, I'd be able to solve for the 4th one using that rule. All right, now so now we got 2 secants meeting on the outside. Again, we're not talking about the angles, we're talking about the segments. That rule, it's kind of an obscure rule, but I like to write outer times whole, like the whole thing, equals outer times whole. And so the way this works is the outer for this one is going to be W. So we say W. The whole is W plus X. So this is the whole, W plus X. Over here, for the one at the bottom, we have the outer as Y. And similarly, you multiply that by the whole, which is Y plus Z. So as you might suspect here, we'll be doing some distributing to solve some of these. But that is the formula for that one. And I don't memorize it as W and X and Y and Z. I say outer times whole equals outer times whole. Same thing here. You have it's a little bit different in that this is a secant and a tangent as opposed to 2 secants. So there is no outer and whole. It's all outer. So in that case, it's just well, it's kind of the same, outer times whole. But then here I don't have an outer, so we call that the tangent. So I just say tangent squared. Or you could say outer times outer, you know, because that's what it is. It's the outside one. So this is the tangent. This is the outer here. And then the whole would be y plus z. So y is the outer. Y plus z equals t squared. Outer times whole equals tangent squared. So let's use that to solve the next example, and we'll be done with the notes. All right, here we go. So using these formulas here, and they're all randomized. We'll start with number 1. In this problem, if you look at the previous picture, this looks most like the bottom right one. So we're going to use the rule with the outer whole and the tangent. We'll modify it to fit our numbers and variables. So first, let's talk about the outer. Outer is going to be 8. So it's going to be 8. The whole is going to be 8 plus 16. These two added together. 8 plus 16 is 24. So I'm going to write 8 plus 16, but you can write 24 there if you want to. And then here it's just z squared, z times z. So 8 times, let's move that down here, 8 times 24 equals z squared. And 24 times 8 192, and we're going to take the square root of that. So z is going to be the square root of 192. And I don't think that's a whole number. It'll be about 13 point something. So about 13.856. So we'll say 0.86. We'll round that 5 up. All right, that's question number 1. Question number 2, we have two secants meeting on the outside here. So if you look at the formulas, that's going to mostly align with the outer whole one. So let's see if we can fit that into the formula. So we'll start with, I'll just start with the one up here. The outer is 8. And the whole is going to be 8 plus 6. So it's going to be 8 times 8 plus 6. That's going to be 14. And over here, the outer is 7. The whole is y plus, it's 7 plus y, so I'll say y plus 7. Now in this problem, we'll have some distributing that we want to do. So the first thing I would do is go ahead and add the 8 and the 6 to get you 14. Well, we don't have to distribute, but that's probably the route I'll go in this one. And I'm going to distribute the 7y and the 7, so it's going to be 7y plus 49. All right, 8 times 14 is 112. So I'll bring that down here. We're going to subtract 49 from both sides. I'll cancel that out. And 112 minus 49 is what? 63. And my last step is to divide by 7, and that's going to get me 63 divided by 7. So 63 divided by 7 is what? Y is going to be 9. All right, finish it up. This is last one is going to be the part times part equals part times part. So basically how that works is 6.5 and m are on the same we call that a chord. They're on the same line, so we'll do 6.5 times m. And then 7 and 3 are on the same line, so we'll do 7 times 3, which is 21. And we want to divide 21 by 6.5. Looks like we're going to get about 3.23. All right, that does it. Thanks for watching. You got your day 4 lesson in kind of 3 different videos. So hopefully you're able to follow along and get the notes completed. So now you're able to do the day 4 assignment. Best of luck to you. Thank you.